So yeah, welcome all. Welcome to this lecture. Shrikar, can you give me a thumbs up if my voice, video, the presentation is all clear? Please give me a thumbs up if it's clear. Hello, Shrikar, are you there? Yes or no, beta? You can write in the chat box also, or give me a thumbs up if it's clear. My voice, the screen, are you able to see it? Hello. Hello, Shrikar. Are you there? Hello. Shrikar, are you there? Hello. Okay, fine. Let's start. So yeah, we'll be doing revision and then we move on to the PYQs. We have the latest 2023 PYQs here. So we'll discuss this, but let's first get done with revision. So as you all know, in vectors, the triple product part is not there. The triple product part is not there. It is removed from the JEE syllabus, so we don't need to study it. So without further ado, let's get started. Let's see what is a scalar. So scalar is a quantity which has only magnitude, as we all know. Example, mass, length, and temperature. What is a vector? Vector has both magnitude and direction. Right? Quantities which are used in physics, that is velocity, acceleration, force. Right? Next, types of vectors. What is meant by null vector, guys? Null vector means magnitude equals to 0 and no direction. Unit vector. Unit vector means magnitude equals to 1. Co-initial. Co-initial means starting from same point. Starting from same point. Collinear. Collinear means two vectors are lie on the same line of action. Coplanar. Coplanar means lie on the same plane. Free vectors. Now, free vectors means that for mathematics, we can consider every vector as a free vector. We can take any vector and place it anywhere in space without changing its magnitude and direction. Let's see. Next, we have the addition of vectors. In addition of vectors, we mainly have two laws, the triangle law and the parallelogram law. Also, actually do not need the parallelogram law because it is derived from triangle law itself. So what does triangle law says, guys? Triangle law says that if this is a triangle ABC and this is a vector A bar and this is a vector B bar, then the third side will be A bar plus B bar. Third side will be A bar plus B bar, which is called the resultant vector. It is called the resultant vector. Now, similar to triangle law, let me also discuss parallelogram law. So, parallelogram law says that these are the two sides. Let's say A bar and B bar. And this is the parallelogram. Then, if the resultant, that is A bar plus B bar, will be given by the diagonal of the parallelogram, which is starting from the same point. Please note, it should start from same point. This is a parallelogram law. What we have next? We have scalar multiplication. Now, scalar multiplication is very important because we use this in collinear vectors. Right? So, let M be a scalar and A vector be a vector. Then the product MA vector is defined as if M is greater than 0, then the vector will have the same direction. If M is less than 0, then the vector will have the opposite direction. Right, guys? So let's see if this is a vector, A vector, and if I want to write 5A vector, then it will be 5 times the A vector. But if I want to write minus 2A vector, then it will be twice A vector, but the direction will be opposite. I hope you can get it. Let's see what we have next. Position vector, very important. I hope you know. So, position vector basically gives position of P relative to O. That is, if I have AB vector, then AB vector is called position vector of B relative to A. It is similar to the shift of origin concept that we study in coordinate geometry. So, AB vector can be written as OB vector minus OA vector, which is B vector minus A vector. So the most simplest way to write AB vector in terms of its position vector is B vector minus A vector. I hope it is clear. Then next we have is linear combination. So when there are n vectors, A1 vector, A2, A3, A4 and An. And there are n scalars, L1, L2, L3 up to Ln. Then this part, let me highlight it, this part. That is, if we multiply the vector, each vector with a corresponding scalar and add them, what we get is called the linear combination of the vectors. Now, what is meant by linearly dependent vectors? Linearly dependent vectors means their linear combination is 0. Linear combination is 0. So what will be linearly independent vectors? Linearly independent vectors means linear combination is not equals to 0. Not equals to 0. Now, this is very important point. Collinear vectors are linearly dependent and coplanar vectors are also linearly dependent. That means non-collinear vectors will be linearly independent. and non-coplanar vectors will be linearly independent, right? Collinear, coplanar are linearly dependent. Non-collinear, non-coplanar are linearly independent. Chalo. What do we have next? A method or a way to check the linearly independent or linear dependence of vectors. So three non-coplanar vectors are linearly independent, and any four vectors are linearly dependent. I think we already discussed this. And if there are three vectors, A vector, B vector, and C vector, and we have to check if these are linearly dependent or not. Then we just have to check its determinant. Make a determinant of the coefficients, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. And if it is equals to 0, that means it is linearly dependent. If we get not equals to 0, then that means it is linearly independent. Let's see what we have next. The section formula. We have the section formula. Just a second, guys. I hope. Yeah, I think there was some glitch, but now we are fine. Okay, guys. Yeah. So this is the section formula. What is the section formula? It is same as we did in straight lines. So let's say A. Hello. Now it's audible, right? It is showing me the voice is audible. Now it's clear. Shrikar, you are unable to hear me. Why? It is showing me that my voice is clear here. Wait a second. I left and uh, hello. Hi. Now is it clear? Hello. Hello, Shrikar. Hello, Shrikar. Are you able to hear me? Do one thing, rejoin the meeting and then we'll check. Yeah, go rejoin the meeting. Hello. Okay. Shrikar, let's continue. Yeah. So here A and B is a line segment and point P divides it internally in the ratio m is to n. Then the coordinates of point P are given by mb bar plus na bar upon m plus n. Right? Let's see what is externally. If the point P divides AB externally, that means mb bar minus na bar just will get a negative sign. We'll get a negative sign. So let's see what we have next. Next, we have some standard results, guys. What are the standard results? First is the midpoint formula. If it is midpoint, then we can easily get the coordinates of P, right? Which is A vector plus B vector upon 2. Next thing is medians of triangles are concurrent. We all know that. And this point of concurrency is called centroid. It is called centroid. Now, centroid divides these medians in the ratio 2 is to 1. All the medians, guys. Right? What do you have next? For a tetrahedron, sorry, for it's a triangle. So if we have a triangle A, B, and C with position vectors A vector, B vector, and C vector. Right? Then the centroid of the triangle, which is denoted by G. So G vector is given by A vector plus B vector plus C vector. Right? Now, what about tetrahedron? Tetrahedron is a three-dimensional figure. As you can see here, let's say this point is D. So this centroid divides the line segment joining vertex to centroid of opposite face. This is centroid of face G1. G1 is centroid of BCD. G1 is centroid of triangle BCD. So this line segment AG1 is divided in the ratio 3:1 by the centroid of the tetrahedron. And what is the coordinate or position vector of this centroid? It is A vector plus B vector plus C vector plus D vector upon 4. Right? Let's see next. Now we have the dot product. Dot product is defined as A dot B and it is given by mod A mod B cos theta. This is the representation of denoting angle between A vector and B vector. So dot product is always scalar. Next, dot product is commutative. Now here are the 5 cases which are very important. If angle is acute, then dot product is greater than 0. If angle is 90, then dot product equals to 0. If angle is obtuse, then dot product less than 0. I hope you know all these cases, guys. Right? And if theta is 0, here it is 0 degree, here it is 180 degrees. Right? Now, if A and B are parallel vectors, so parallel vectors, we have 2 cases. Either they are like parallel in the same direction or unlike parallel in the opposite direction. The next thing is the value of A dot A is basically A square. Now these are the notations. These are the notations. Let's see the orthogonal, very important, guys. Now, as you know, this triple product is removed from your syllabus. This becomes very important. So, what is meant by projection? Let's say this is the vector A vector, OA vector, and this is the vector B vector. Then the projection or length OM is called the component of B vector on A vector, or it is also called projection. So projection is very commonly used, but component is rarely used. Now, if we take the vector OM vector, then it is called vector component. How can it be given? See, the component or projection of B on A is B bar dot A bar upon mod of A bar. B bar dot A bar upon mod of A bar. Right? Orthogonal projection means vector component. What will be the vector component, guys? The vector component will be B dot A upon A square into A vector. Next, we have geometrical interpretation of dot product, which is A dot B is A into component of B on A. Why? Because if you see this length, if this angle is theta, this is A, this is B. So this will be A cos theta. Just a second. Yeah. Yeah. This was A vector, B vector. This will be B cos theta. So what is dot product, guys? Dot product is A into B cos theta. What is the component of B on it is B cos theta. The dot product is distributive in nature. Correct? Let's see what we have next. How to find dot product? Very simple. Just multiply their coefficients. Just multiply their coefficients. So we'll get the dot product. So similarly, for unit vectors I, j, and k, we can easily get the dot product.